we got Dr. Dustin Harrell, who used to be the rice specialist, and now you're the research coordinator or the director of the Rice Research Station in Crowley.
That's correct.
And you're still doing research agronomist.
That's right. Still the research agronomist.
So anyway, all right.
Well, I appreciate the opportunity to be here today to talk a little bit about this year, talk a little bit about our research projects, which we don't get to talk a lot about when I was doing a lot of the extension work, because we focused a lot on the extension. So now we're going to talk a little bit about some of the research that we're doing and how it relates to what you can look forward to in 2021. Okay. Just in general, our research project is focused on the fertility and agronomy project, and our overall objective is to enhance rice production in Louisiana by improving nutrient and cultural management practices. To that end, our research project had 5 different locations last year, where we had over 115 separate replicated field trials, and we managed over 4,812 plots across Louisiana last year, focusing on fertility and agronomy. One of the main things that we like to do in our fertility program is we work hand in hand with the breeding group. So if the breeding group has a new line that looks very promising, what we want to get in there and look at that from an agronomic perspective. That way, when that variety is released, we also have an agronomic package to go with that particular variety. In other words, what are the optimal nitrogen rates we need to fertilize with that variety? And what is the optimum seeding rate? And we do a lot of plant population studies with some of these new varieties. So 2021, you're going to see a lot of changes as far as varieties go in the state of Louisiana. One of the first things, we have several new varieties that are being released. And one of the new varieties is PVL03. PVL03 is going to be the 3rd edition of our Provisia lines. It's only going to be on a limited release next year, so it's only going to be a few acres. But it's really exciting to look at this new Provisia line because what we have in it now is the new PETA gene, which is going to give it blast resistance. So if you know how we progressed with the Provisia lines, the first Provisia line came out very quickly, had limited yield potential compared to our other varieties out there, and it was very susceptible to blast. PVL02 was released last year on a limited basis, and this year we'll see a lot of PVL02. PVL02 answered the yield part of the equation, so we had a big increase in our yield. It also retuned very well, which PVL01 did not retune hardly at all if you're in South Louisiana, but it was still very susceptible to blast. Now with PVL03, we have the higher yield, we have the blast resistance, and it will retune as well. So it's pretty exciting to see PVL03 come out next year. But it is only going to be on a limited amount of acres, depending on how the seed production, how much seed they produce in South Texas, which is growing right now. The next new exciting variety that's going to be out there next year is DG263L. Now, DG263L is a conventional long grain variety. This was not developed by any of the university systems. It was actually developed by Nutrient. So it's going to be the first time we're going to have a release from a non-university system. Now the DG263L is pretty exciting because it's flat out going to be the highest yielding non-hybrid variety that we have out there, hands down. We've seen it across multiple years. It's been the highest yielder in most locations. And in fact, if you look at the Rice Varieties and Management Tips publication and you look at the variety trials across the state, you'll see that the DG263L actually yielded just as well as CLXL 745. So it's telling you it's going to be our highest yielding variety out there, and it's going to be on the lower end of the hybrid. DG stands for Dynagrow, so it's going to be a named variety out there. The only negative thing that we saw with DG263L is that the milling was a little bit lower than our other varieties. It had more brokens in it. The whole milling was pretty similar, but it had more broken in it as compared to our other conventional long grains out there. The third new variety you're going to see out there next year is CLL17. CLL17 was developed by Dr. Adam Formoso at the Rice Research Station. It is a clear field long grain. CLL17 has good yield potential. very good disease resistance. And one thing that you're going to see next year is CL153 this is going to replace CL153. There's not going to be as much seed production as CL153, so it's going to be out there on a very limited basis. So if you have a grower that grew CL153 last year, they're probably going to replace it with CLL17. And that's very significant because CL153 was our highest number of acres of a variety that we had out there. It represented 19.5% of the rice acres in the state of Louisiana. And so we only have about 1% of the seed next year, so CLL17 is going to be the direct replacement for that. And we'll talk a little bit about how to manage CLL17. All right. Well, I clicked it a few times, just took the... All right, so first we're going to talk about the nitrogen response of the Dynagrow 263L to nitrogen rate. This is the nitrogen rate trial, typical of what we do with our nitrogen rate. On the x-axis, we have our nitrogen rates, single pre-flood before the dotted line, our split nitrogen rates past the dotted line. That's our yield on the y-axis. You can see that as we increase our nitrogen rate, we increase our yield to a certain point, and it kind of steadies off. That's typical of what we see with the nitrogen response trial. Here you can see the 263 on a silt loam soil in South Louisiana. 90 pounds of nitrogen per acre was optimum as a single application, and when we split, it was 120 pounds of nitrogen per acre, which is very typical of most of our semi-dwarf varieties out there. So from a nitrogen rate standpoint, it was very common. Now we also did this at St. Joe Research Station on a clay soil, and here you can see again we have an increase in yield as we increase our nitrogen rate, and on the clay soil we see that 120 pounds of nitrogen was optimum, and 150 when we split the nitrogen rate. So very typical of what we see on a clay soil. So typically on a silt loam soil, we usually get away with about 30 pounds less nitrogen as compared to the heavy clay soils. Now we did have some lodging with this variety at the St. Joe station, but this was after a tropical storm, and our data was still pretty good afterwards. So we don't really have any, we're not real nervous about this particular variety lodging on us. It was just, this was subject to heavy winds near harvest time. The optimum recommendation is going to be 120 to 150 pounds of nitrogen for this particular variety. DG263L, when we looked at plant population studies, here you can see our seeding rate on the x-axis and our plant population on the y-axis. What this is telling us is that we have about 72% of the seed that we planted survived to the 3-leaf stage of development, indicating that we have pretty good seedling vigor for this particular variety. So it's a very vigorous variety. When we looked at the optimum plant population to maximize yield, again, we found that the optimum plant population for this variety is about, in this study, was about 12.9 plants per square foot. Our current recommendations for our variety is anywhere between 10 and 15 plants per square foot to maximize yield. So again, you can see that this variety fits in with most of the other varieties that we're growing rice at as far as the plant population. Here you can see it on a clay soil. This is at the St. Joe Research Station. Here you can see at the St. Joe Station where we have the clay soil, only 64% of the plants that we planted actually survived to the 3-leaf stage development. So it's typical of what you see in the clay soil. We're not going to have as many survive. But for our general recommendations for this variety for 2021 is going to be 50 to 70 pounds per acre recommended for drill seeding. If you're water seeding this particular variety, 70 to 90 pounds seed per acre. Switching gears a little bit, here's our Clearfield long grain, the CLL17. Again, this is going to be a big shift from CL153 next year. CL153 had about 19.5% of our total acres in the state of Louisiana, and the CLL17 will be the direct replacement for it. Here's a response to nitrogen for CLL17. Again, we have a typical nitrogen response. Optimum nitrogen rate at the silt loam soil in Crowley was 120 pounds of nitrogen per acre. We also had 150 pounds of nitrogen per acre when we started splitting the rates. Now, we didn't have any problems with lodging in our studies for this variety in Louisiana. We did see a little bit of lodging at our higher nitrogen rate, but there was a considerable amount of lodging in Arkansas and a little bit in Mississippi. And because of that lodging, we're going to be very careful with our nitrogen for this particular variety for next year. We're going to be recommend on the low end for nitrogen, just like if you've ever grown CL 151, if you ever grown that variety, you know how we have to limit it for nitrogen because of lodging. We're going to do the same thing for CLL 17. Our recommended nitrogen rate is going to be 90 to 130 pounds of nitrogen per acre. And that's very precautionary because we have seen some lodging with this variety, and it is going to be labeled moderately susceptible to lodging. So that's the only problem with this particular variety. And it might come to that in the years, as we learn more this year, as it gets in commercial production, maybe it stands a little bit better than we think it's going to stand, and we can have normal nitrogen rates. But if you've ever grown CL 151 or Jupiter, similar on a nitrogen perspective, we're going to limit that nitrogen compared to the other varieties. So, talk a little bit about furrow irrigated rice. As you know, furrow irrigated rice has become very popular in the state of Louisiana as well as in Arkansas and Mississippi. Just to give you an example of how popular it's become, we take a survey every year where we talk about the different varieties grown in the state and how they're managed. And in 2017, I inserted furrow irrigated rice into that evaluation, into that survey. And we saw that in 2017, we only had 2,500 acres of furrow irrigated rice in the state of Louisiana. In 2018, that doubled to 5,000 acres of furrow irrigated rice. In 2019, we had over 15,000 acres of furrow irrigated rice, so we tripled in 1 year. And then in 2020, last year, we saw that RMA gave us the opportunity to insure furrow irrigated rice as well as alternate wetting and drying. And because it was an add-on insurance that you could get, we actually saw our furrow irrigated rice again jump in the number of acres in the state of Louisiana to over 35,000 acres of furrow irrigated rice. That represents about 7.5% of the total acres in the state of Louisiana is grown in furrow irrigated rice, and 100% of that furrow irrigated rice is right up here in northeast Louisiana. Now, there's a lot of things that we don't know about furrow irrigated rice as it comes to management of it as far as nitrogen. Because you're in a system where you're constantly wetting that soil, especially at the top of the paddy, and then drying it, and then wetting it, and drying it again, it becomes very inefficient as far as nitrogen use efficiency. And because of that, we have to manage it differently. We know that because it's less inefficient, one way that we can gain some of that efficiency back is if we add split application or start spoon feeding that nitrogen to it, little doses at a time. That'll actually increase the efficiency of the nitrogen, but it also adds cost to the production side because of the multiple applications. But we'll talk about some of our research that answers some of this and looks at what is the optimum nitrogen rate for furrow irrigated rice, what is the optimum timing of spoon feeding. Do we need to apply one application, two applications, three applications, or four applications? And how much time between those applications is optimum? Is it 7 days? Is it 14 days? How should we manage that? We also have some studies that looked at different nitrogen sources, looking at nitrification inhibitors as well as urease inhibitors. As you know, in our drill-seeded upland delayed flood rice production system, we only need a urease inhibitor. We don't need a nitrification inhibitor because in that we can get the water established, the flood established on the field. That'll actually stabilize our ammonium nitrogen. But in furrow irrigated rice, you go from anaerobic to anaerobic to anaerobic to anaerobic. So now not only do we have ammonium, but it's going to go through nitrification and turn to nitrate. And then when you put saturate it and it goes anaerobic, that nitrate is going to be lost over the field. Just like if you have a water standing on the field on a corn plant, and you see where water pools up and you lose nitrogen that way. Same thing with furrow irrigated rice. So we're doing this not only on a silt loam soil, but we're also doing it some of this research on a clay soil at the St. Joseph Research Station. And graduate student Melanie Netterville is heading up that all these trials. All right, so this is the first trial that we're looking at. This is just looking at the different nitrogen rate in furrow irrigated rice as compared to flooded rice. On the blue, we see our flooded rice, our typical drill seeded delayed flood rice production system. In the orange bars, we see our furrow irrigated rice. This is our nitrogen rates on the x-axis and our yields in the y-axis. Now, the first thing we're looking at is just the differences in nitrogen amounts to maximize production. Now, granted, this is only a single nitrogen application, so we're not spoon feeding at this point, but what we're just trying to show you is give proof that you do need more nitrogen because it's less efficient. Here you can see if we just use one application, you can see that the optimum amount of nitrogen goes from 120 on flooded rice to 150 pounds on furrow irrigated rice. Here we can look at a trial that looks at different nitrogen application timings as well as nitrogen rates in furrow irrigated rice. This is for CL153 at the Rice Research Station, which is on a silt loam soil. And here you can see we applied nitrogen at two different rates. The yellow lines are 120 pounds of total nitrogen that we applied. The blue is 160 pounds of total nitrogen that applied. And then we applied this nitrogen in multiple ways. We either put it all as a single application, or we applied as a two-way split application 7 days apart, or we did a two-way split application 14 days apart, or we did a three-way split application 7 days apart between each of those nitrogen applications. And remember, we're applying the same total amount of nitrogen. And here we can see that the optimum rate or optimum application timing was that two-way split 14 days apart or the three-way split 7 days apart. They were superior to the single application, which we knew, or the two-way split 7 days apart. Same thing when we look at the higher nitrogen rate of 165 pounds per acre. Again, the two-way split 2 weeks apart and the three-way split 7 days apart were superior to the two-way split 7 days or the single application. Just to talk a little bit about nitrogen in our flooded scenario, I like to cover this a little bit more because as I was extension, I didn't cover it as much as I can now. I have a little bit more time to talk about this. But in fertilizing nitrogen for rice in the state of Louisiana, we really only have three simple rules. Number one, we're only going to use ammonium or ammonium-forming fertilizer like urea in rice production. The reason why we only use ammonium or an ammonium-forming fertilizer is because ammonium under flooded anaerobic conditions is stable, and the rice can take it up at any time as long as you keep the flood on the field. We never want nitrate nitrogen fertilizers in flooded rice production because nitrate nitrogen under flooded conditions will be lost through a process called denitrification, and it'll be lost as a gas off the field. In our flooded rice, we want that first application to be applied on a dry soil just before a permanent flood establishment. We're going to apply about 2/3 of our seasonal need at this time. And then we're going to come back at mid-season and apply our remaining 1/3 of our nitrogen needs. For that initial pre-flood nitrogen application, if it takes longer than 3 to 5 days to flood the field, we're going to recommend you use a urease inhibitor applied on that urea to stabilize that nitrogen and keep it floating away as ammonia gas. And typically, you can use any urease inhibitor, but we want to make sure that you're using only NBPT as the active ingredient, NPPT, which is the BASF product, or Duramide, and those are our only three active ingredients for urease inhibitors that we recommend. So it's NBPT, NPPT, or Duramide as our recommended urease inhibitors for flooded rice. Just to go over what this does for our rice production. This is a study that we did several years ago just to illustrate how important it is to stabilize that nitrogen. Here on the x-axis, we have nitrogen or urea fertilizer that was left on the soil exposed for 10 days prior to permanent flood establishment, 7 days before flood establishment, 4 days before flood establishment, and 1 day before flood establishment. You can see that the less time that we leave it exposed on the soil surface, the higher yields that we have, and that's directly related to the nitrogen loss that we have from ammonia volatilization. So what happens if we treat that urea with the urease inhibitor? Here you can see untreated urea, and here you can see that urea treated with NPPT. In this case, we use agrotane. Now you can see no matter if we're at 10 days, 7 days, 4 days, or 1 day prior to permanent flood establishment, we stabilize that nitrogen and we stabilize that yield. That's exactly why you want to use a urease inhibitor on your urea if you're going to leave it sitting on the soil surface prior to establishing your flood. So there's a lot of different urease inhibitors out there. Again, we want to use NBPT, NPPT, or Duramide. So there's a lot of different brand names out there. It doesn't really matter what brand name you use. Just be sure to look on the label. Make sure it has one of these active ingredients at a concentration that's high enough with that active. So one of the things that we looked at this last year, as you know, Simplot has moved in and into Louisiana. And anytime we had G&H, they changed to another company name, Sanders, and then now they've changed to Simplot, and Simplot has some other places as well. But what I want to do is do a study looking at their products as compared to some of the other ones out there. And in this study, we were looking at Simplot products. Here we had 4 different nitrogen sources. We had urea. We had their product called Volterra. Volterra is actually DCD plus NBPT treated on urea. We had their Invale product, which is NBPT alone. And then we had their product that was Preserve N. Preserve N was a DCD product at 18%. And then we also looked at their Preserve N plus Invale, which was the DCD, which is a nitrification inhibitor, and the Invale, which is their NBPT product. And all these were treated on urea, applied on the soil surface, and we waited 10 days prior to establishing our permanent flood. In this trial, you can see that this is our no fertilizer. We had the lowest yield. As we looked at urea, yield increased. And then we added our Volterra, which is NBPT, the urease inhibitor, plus the DCD product. You see we increased our yield. NBPT alone had the same yield response in our flooded rice. DCD alone really didn't give us any benefit at all. And then when we had, again, the NBPT by itself with the Invale product applied separately, again, our yields increased. The bottom line is, in flooded rice, we only need NBPT or urease inhibitor. You do not need a nitrification inhibitor in flooded rice for this reason. However, and for our irrigated rice, your nitrification inhibitor is probably going to give you a benefit because you're going from wet to dry to wet to dry. So flooded rice, you need NBPT. For our irrigated rice, NBPT plus your nitrification inhibitor, which is DCD. With that, I'd like to thank you for giving me the opportunity to speak again at the meeting. And even though I'm not the extension specialist anymore, feel free to contact me at any time. This is my contact information. Dr. Levy will be taking over the field notes, but if you're interested in that, we can get you on the mailing list. We also have the Twitter at Louisiana_Rice, and we also have our text message group that you can get on that as well. I think we have over 360 people on our text message group, and during the growing season, if we have any kind of issue or a new publication, we try to send that out over text. So with that, if there's any questions, I'd be happy to answer them.